Welcome to Chapter 12 Problem Solving. I'm Angelo Calta. Problem 12.2. A cube, 5 centimeters on each side, is made of a metal alloy after you drill a cylindrical hole 2.0 centimeters in diameter all the way through and perpendicular to one face. You find that the cube weighs 6.3 newtons. What is the density of this metal? A. B. What did the cube weigh before you drilled the hole in it? So for the volume of the cube, we first have to convert the 5 centimeter measurement into meters and then cube it, which will give us 1.25 times 10 raised to the negative 4 meters cubed. And then for the volume of the cylindrical hole, it's pi r squared times height. Given that r is 0.01 meter and the height is 0.05 meters. This will give us a value of 1.57 times 10 raised to negative 3 meters cubed. And then we will subtract the volume of the cylindrical hole to the overall volume of the cube to get the volume of the cube with the hole drilled on it. So the volume of the cube with the hole is 1.093 times 10 raised to negative 4 meters cubed. So the mass of the cube with hole is 6.3 newtons divided by 9.8 meters per second squared, which is gravity. This will give us 0.642 kilograms. And then to get the density of the metal in the cube with the hole, we will use the formula M over V. So given that the mass of the cube with the hole is 0.642 kilograms, divided by the volume of the cube with the hole, which is 1.093 times 10 raised to the negative 4 meters cubed, we will get the result 5,873.74 kilogram per meter cube. For B, we'll just plug in the density we got from letter A and multiply it by the original volume of the cube without the hole. This will give us that cube weighed 0.7342 kilograms before we drill the hole in it. Problem 12.9. Scientists have found evidence that Mars may once have had an ocean 0.800 kilometers deep. The acceleration due to gravity on Mars is 3.71 meters per second squared. A. What would be the gauge pressure at the bottom of such an ocean, assuming it was freshwater? B. To what depth would you need to go in the Earth's ocean to experience the same gauge pressure? So, this problem is very simple. For letter A, you have to use the formula pressure equals initial pressure plus density times gravity times height. So, assuming that the initial pressure in Mars is 0, we will just plug in the density value for water, the gravity of Mars given, and the height, 800 meters. This will give us 2,968,000 kilogram per meters times second squared. And then to get the height, you need to go into the Earth's ocean to experience the same gauge pressure. We will use height equals pressure minus initial pressure over density and times gravity. This will give us an answer of 301.8 meters. So we use 10,335 kilogram per meter squared as the initial pressure because it is the Earth's pressure on Earth's surface. So you would have to go 301.8 meters down the Earth's ocean to experience the same gauge pressure. 12.26. A rock has a mass of 1.8 kilograms. When the rock is suspended from the lower end of a string and totally immersed in water, the tension in the string is 12.8 newtons. What is the smallest density of a liquid in which the rock will float? So the force of the weight of the rock is simply 1.8 kilograms times 9.8 meters per second squared. This will give us 17.64 newtons. And then the summation of forces is buoyant force plus tension force minus force of the weight of the rock equals 0. So to get the buoyant force, you will mind subtract the tension force from the force of the weight of the rock. This will give us 4.84 newtons for the buoyant force. And then to get the volume of the displaced water, we have to divide the buoyant force by density times gravity, density of the water. This will give us 0.00049 meters cube for the volume of water displaced. And then to get the density of the rock, we will have to divide the buoyant force on the rock only without the tension on the string divided by volume times gravity. The volume is the volume of the water displaced we calculated previously. This will give us 3,644.62 kilogram per meter cube as the smallest density of a liquid in which the rock will float. Thank you for listening and I hope you learned something.